Hi everyone, this is the second part of my lecture on problem solving with patterns. My lecture will focus on harmonic and geometric sequence. And at the end of the lecture, you are expected to be able to identify a harmonic and geometric sequence, solve the nth term of harmonic and geometric sequence, and be able to solve for the sum of the n terms in a geometric sequence. Another type of sequence that a given list of numbers may form is the harmonic sequence. A harmonic sequence is a sequence of numbers whose reciprocals form an arithmetic sequence. Let us have this example. Find the next term in the sequence 1/2, 1/5, 1/8, 1/11, and so on. So our first attempt in solving sequence of numbers is to determine if you can find an equal difference of consecutive terms. So you can try that one in the original given sequence of numbers. But you will notice that at any level of differences, there is no common difference. And so therefore, we can proceed with trying to observe the reciprocals of the given terms. So the reciprocal of these terms in the original sequence will be 2, 5, 8, and 11. So we have now again another list of numbers in here. So we try to find out what sequence it formed. So we again try the common difference, and you will notice that difference of consecutive terms, that is 5 minus 2, 8 minus 5, and 11 minus 8 have equal difference, which is equal to 3. So we call 3 as a common difference, and so therefore the sequence of the reciprocals of numbers form an arithmetic sequence. And we can find for the next term in this arithmetic sequence by adding the common difference to the last term. So we have 11 plus 3 is equal to 14. And so going back to the question, find the next term of this given sequence. So we therefore have the terms will be 1/2, 1/5, 1/8, 1/11, and the next term is 1 over 14. Let us have another example. Find the next two terms of the sequence 1/4, 1, -1/2, -1/5, and so on. So we usually start our solution with finding out if successive terms have equal differences. So we have 1 minus 1/4 is 3/4, -1/2 minus 1 is -3/2, and obviously in here looking at the first two differences, they are not equal, and so therefore the given sequence do not form an arithmetic sequence. So let us try to find out if the reciprocal form another or form an arithmetic sequence. That is, we try to find out if their difference are equal or successive difference of successive terms are equal. 1 minus 4 is -3. -2 minus 1 is -3. -5 minus -2 is -3. So having these differences equal, that means the reciprocals of the terms form an arithmetic sequence, and therefore the original given sequence is a harmonic sequence. So to find for the next term in the sequence of the reciprocals, we're just going to add a common difference to the last term. So we have -5 plus -3 is equal to -8. And then -8 plus -3 is equal to -11. And so the next two terms in the harmonic sequence 1/4, 1, -1/2, -1/5 are 1 over 8 and -1 over 12. Let us solve this problem to find for the next two terms of the sequence 3, 6, 12, 24, and so on. So again, we start our solution by trying to observe the difference between successive terms. So we have 3, 6, 12, 24, and we're required to find two more terms in the sequence. So the first difference will be 6 minus 3 is 3, 12 minus 6 is 6, 24 minus 12 is 12. So you will notice that we do not have equal first difference. However, we can observe pattern that the first difference are following. So we have in here 3, 6, and 12 actually are the first three terms in the sequence. So therefore, following that pattern, the next difference will be 24. So 24 plus 24 will give us 48. And the next difference will be 48. Added that one to 48, it will give us the next element, which is 96. So the next two terms then of the sequence 3, 6, 12, 24 are 48 and 96. Okay, notice that this process of finding the nth term of a given sequence is convenient only if n is small. So in here we are required to find for the fifth and the sixth term. Obviously, it would take time if n is quite a large number. So in the next slide, I am going to discuss shortcut on how you are going to find the nth term of a given sequence following this form. Another type of sequence that a list of numbers may form is a geometric sequence. A geometric sequence is formed if the ratio of consecutive terms are equal. And this equal ratio is what we call the common ratio. Let us say we're given a sequence of numbers in here, a sub 1, a sub 2, a sub 3, a sub 4, and so on up to the last term, a sub n. If the ratio a sub 2 over a sub 1 is equal to the ratio a sub 3 over a sub 2, a sub 4 over a sub 3, then this sequence formed a geometric sequence. And the common ratio is the ratio a sub 2 over a sub 1, which is equal to a sub 3 over a sub 2 equal to a sub 4 over a sub 3. So also if R in here in this equation, if R is equal to a sub 2 over a sub 1, that means a sub 2 is equal to a sub 1 times R. Also, R is equal to a sub 3 over a sub 2. So that if we solve for a sub 3 then is a sub 2 times R. But since we already know in here that a sub 2 is equal to a sub 1 times R, and so we therefore have our a sub 3 is equal to a sub 1 times R squared. Also, R is equal to the ratio a sub 4 over a sub 3. So from this equation, we can solve for a sub 4. We have a sub 3 times R. But since we have already solved in here, a sub 3 is equal to a sub 1 R squared times this R, that gives us now a sub 4 is equal to a sub 1 times R cubed. So you will notice now in here the pattern formed by each term in the geometric sequence. So when we have in here a sub 2, we have a sub 1 R raised to 1. Our a sub 3, we have a sub 1 R raised to 2. Our a sub 4 is equal to a sub 1 R raised to 3. So we have now the formula for the nth term of a geometric sequence. That is, a sub n is equal to a sub 1 times R raised to n minus 1. And we can now make use of this formula to solve for or to determine the desired nth term in a geometric sequence. Let us solve this problem to find for the 5th and 13th terms of the sequence 3, 6, 12, 24, and so on. So you can start your solution again by looking at the difference between consecutive terms. So you will notice that you will not be able to get equal difference. So we try to find out if these numbers form a geometric sequence. That is, try to find out if the ratio between 6 and 3 is equal to 12 over 6 equal to 24 over 12. So obviously 6 over 3, 12 over 6, and 24 over 12 are all equal to 2, and so therefore the terms in the given sequence form a geometric sequence, and the common ratio R is equal to 2. So to find for the 5th term, since we're already given in here the first 4 terms, so immediately we can find for the 5th term by multiplying the common ratio to the 4th term. So we have a sub 5 is equal to a sub 4 times R. giving us 24 times 2, or a sub 5, the fifth term is equal to 48. To find for the 13th term, let us now make use of the derived formula. That a sub 13, or from the formula a sub n, is equal to a sub 1 times r raised to n minus 1. That means a sub 13 is equal to a sub 1 times r raised to 12. And so substituting values, we now have a sub 1 is 3, r is equal to 2 raised to 12. Using your calculator, you have now your a sub 13 is equal to 12,288. Let us solve this problem to find the first term of the geometric sequence whose seventh term is 500 and common ratio of 5. So we start our solution. We are given a geometric sequence whose seventh term a sub 7 is equal to 500 and the common ratio r is equal to 5. Since we are required to find for the first term, we make use of the formula for the nth term. A sub n is equal to a sub 1 r raised to n minus 1. So the seventh term will be written in the form a sub 7 is equal to a sub 1 r raised to 6. Substituting the values, a sub 7 is 500 and r is equal to 5. And using your calculator, it gives us the value of a sub 1 equal to 32 hundredths, or 0.032. Let us now derive a formula in finding for the sum of the terms in a geometric sequence. So the sum is called the geometric sum or geometric series, denoted by symbol S sub n. So if let us say we're given a geometric sequence a sub 1, a sub 2, a sub 3, and so on up to a sub n, and the common ratio is equal to r. The sum of these terms in the geometric sequence, let us denote that one as equation 1, will now be equal to a sub 1 plus a sub 2 plus a sub 3, and so on up to a sub n. Okay, since we have already derived a formula where we can express now each of these terms in terms of a sub 1 and r, so we can substitute the values of the terms. Let us denote this equation as equation 2. So we have a sub 1. We know that a sub 2 is a sub 1 times r. A sub 3 is a sub 1 r squared. A sub 4 is a sub 1 r raised to 4 minus 1, or 3. Then a sub n minus 1 is a sub 1 times r raised to n minus 1 minus 1, or r raised to n minus 2. A sub n is equal to a sub 1 times r raised to n minus 1. So we have now the second equation for the sum of the terms in a geometric sequence. Okay, so if we are going to multiply equation 2 times r, the common ratio r. So we are going to multiply each of the terms in this equation by r. So the left member will be, so you have now r times a sub n, multiplying a sub 1 in here by r will give us this. Multiplying a sub 1 times r is a sub 1 times r squared. A sub 1 r squared times r is a sub 1 r cubed. A sub 1 r cubed times r is a sub 1 r raised to 4, and so on. And the second to the last term, if we multiply this one by r, notice that will give us a sub 1 r raised to n minus 1. And multiplying a sub 1 r raised to n minus 1 times r will give us a sub 1 times r raised to n. Okay, so comparing now this equation 2 and equation 2a, if we are going to subtract equation 2 minus 2a, this will give us now, the left member we subtract s sub n minus r times s sub n. So it gives us this. Notice at the right side, this term cancels out with this. This two cancels out. This cancels out. So you have in there, these terms cancels out. So when we subtract also the right members of the two equations, what is left is a sub 1 minus a sub 1 r raised to n. So in the left member, s sub n is common. We can factor that out. So we have s sub n times 1 minus r. So the right side, we have a sub 1 minus a sub 1 r raised to n. We are now ready to solve for s sub n. we have a sub 1 minus a sub 1 r raised to n all over 1 minus r. So since a sub 1 in here is common, we can factor that out. We have a sub 1 times 1 minus r raised to n all over 1 minus r. So this is now the formula for the sum of n terms in a geometric sequence. So we use this formula if we know the first term, we know the ratio, the common ratio, and the number of terms in the sequence. So an alternative formula can be used by substituting now the value of, or we know that in this factor a sub 1 r raised to n, we can express that one as a sub 1 r raised to n minus 1 times r. And we know that this factor is equal to a sub n. Okay, so we have now another formula for the sum of the terms in a geometric sequence that will give us now a sub n is equal to a sub 1 minus a sub n times r all over 1 minus r. So this formula is used if you know the first term, the last term, and the common ratio r. Okay? Let us solve this problem to find for the sum of the sequence 3, 12, 48 up to the 9th term. So we start our solution by finding out if the sequence formed an arithmetic sequence. And since they do not have equal difference, so we proceed with trying to find out if this is a geometric sequence. So we have to look for a common ratio, that is a sub 2 over a sub 1 must be equal to a sub 3 over a sub 2. And so 12 over 3 is equal to 4, 48 over 12 is equal to 4. That means the common ratio is equal to 4. So to find for the sum of the first 9 terms, we use the formula S sub n is equal to a sub 1 times the quantity r raised to n minus 1 all over r minus 1. So for the first 9 terms, our S sub 9 is equal to a sub 1 times the quantity r raised to 9 minus 1 all over r minus 1. Substituting now the values, S sub 9 is equal to a sub 1 is 3, r is 4, raised to 9 minus 1 all over 4 minus 1. Using your calculator, that will give us now the sum of the first 9 terms in the geometric sequence is equal to 26,214. I'll end up my discussion in here. I hope you will be able to apply the principles you learned about arithmetic sequence, harmonic sequence, and geometric sequence in solving application problems. Thank you for watching.